the construction tube. This was a tube built by one of the contractors we worked for. And so this has the 12-inch diameter. And on top of it, connected to more Ely and coffee cans. Now, those of you who are interested in playing with Ely coffee cans, it is a wonderful material. As I said, it's easy to store. All you need is a 100 watts or higher wattage starter. But when you put the top cover it to the bottom, you can actually snap it. So this will make it easy to adjust the height to get a good. But anyway, yeah, this back to the asymmetric dipole, vertical dipole. These both are actually so-called resonators. So one is tuned to the 17, another 15, and another 20. And with this, I can have very good resonance in all these three. And I can change this, with any frequency from 20 to 10. And you can get the perfect resonance. You don't need a tuner to operate your transceiver. Okay, that's my big item. But that was saying during the pandemic, I was tinkering with all kinds of things. One of the items is a certain vertical antennas, but the base load. But one of the differences between this and most commercially available antenna is that it's a very fast base coil. This makes it very, very efficient. And this can actually extend up and down so that you can have the very fine tuning. After you roughly tune it to a different place where you have the coils. Now, I have a whole bunch of transceivers I built in the past 3 years. They were the QRP and QRPT. You're welcome to take a look at it. The reason why I have been working with QRPT is a few years ago, I wanted to experiment with potato patterns. It started out as a joke, but I decided to figure out how much power potatoes and other vegetables and fruit can use. So I experimented with bananas and avocados and so forth, and the potatoes turn out to be rather difficult. Meaning, single potato, when it's boiled, it can produce like 10 milliamp. That's a pretty, and then about 1 volt. Most fruits and vegetables I found out have anywhere from 0.5 volt to 1.2 volt. And of course, the current is not very large, but as I said, when you boil it, the current increases almost by 10-fold. And this is not my own discovery. Somebody in the Jerusalem University of Jerusalem, Israel, wrote a paper several years ago saying that it can actually produce up to 10 times once you boil, 10 times of the amperage. But anyway, so I wrote an article. I don't know if anybody never seen it, but April USD 2 years ago, and showing that you can actually create transceiver. Uh, of course, if you are PP, actually, a few milliwatts of output using the potatoes. And for that experiment, I have to produce really a QRPP transceiver. And for the transmitter, this is one of them. And this is simply a computer oscillator, computer timing oscillator. And some of them fall within the end band. And this particular one is 14318.
Yes, I'm doing.
A single.
I'm sorry, Corky, you need to start winding it up, unfortunately.
Okay. All right. I'll quit. But can I show one more thing?
Go ahead, go ahead.
Many of you know the Electraft, terminal Electraft just came out with KH1, which is a wonderful handheld transceiver, CW only, but multi-band. It's totally self-contained. It's a great transceiver. The problem is that the price tag. By the time you add all the options, it's $400,000. So it's a great radio, but it, for that reason, that's a kind of radio for people who too much money to do home school. So I decided to build my own with 4 months KH1, which I call KH2. But it works very well and actually more capable than KH1 because it can do SSD, not just CW. And actually inside is the true SDX, the high band, if you are familiar with that, cheap Chinese software controlled the radio. And I built the paddle attached to it using the old switches I have picked up in flea market. Okay, I have a few more things, but I stop now. I don't.
Well, you know what, you can, thank you very much. We can, if you leave your stuff here or wherever, by all means, later on, you can go over more stuff. So Haruki was one of the first persons to sign up, and he says, I have quite a bit, and at that time, no one was signing up, so I said, sure, I'll give you a little bit more time, and of course, look what happened. So I'm sorry about that. Ben, KO6CNT, you're up. You good to go right now? All right. Oh, certainly can. Let's cue that up. We may have to check with this. There's a keep going, and then the other, oh, that should work. And if you just move some of the other stuff out of the view. And then the question is if it's backwards or forwards, but you'll figure that out. We can turn on that, like, well, it'll actually, but is it too much? It has a adjustable. Oh, nice. There you go.
Okay, I'm gonna keep it short because this is a software only thing. So when I started doing ham radio, it was kind of hard getting call signs, the names, and I was searching up on the ULS website. If you know, FCP has the ULS website where you can search up call signs, but it takes like a minute to load, and that was just too much for me. So, I made an iPhone app that can search call signs, and yeah.
And what are you actually searching there?
So I searched my call sign and it just pops up with my name, just class, address, and then it gives a map view of where the person is. So it's very easy to use, and that was like half a second, a second. And then you could save call signs. Like I already have this one saved.
You're gonna see this on the App Store anytime soon?
Yeah, this is on the App Store.
Cool.
Uh, so I will be learning Android development because I learned iOS development. So I'm planning on making an Android version of that. It's quite simple, so I can just rewrite it in Java. So this is written in Swift. Uh, just-
Look on the screen behind you to see where your image is.
Yes.
yeah.
There we go.
Almost. Look behind you.
Yeah, so it has staying views.
We're gonna switch the camera after this. Once again, another
So you can just say this can kind of act like a log, but you can just say people. That's pretty much it.
All right.
Max thing about it. Yeah.
You have to pay for Apple development software to like that?
Yeah, you have to pay like $100 for some reason. Apple makes it that you can only do it if you're over 18, so I made a second account. Yeah. But if you want to install it, it's Ham Searcher on iPhone, iPad, and Mac. So if you have any of those, you can just install it. Ham Searcher.
Oh, good job.
So for you that haven't been here in the last few meetings, Ben's a new ham, and he also is running up a nice little club over there at which high school is it? Wilcox. There you go. All right, Miko, you're up. I have that table for you.
I don't need anything. You don't have everything I need.
Okay.
So, when you do receiver testing, let's think about FM,
Can
you
you
know,
flip that camera?
dual band radios, FM receiver, you're testing them out. And you want to do the sensitivity test, you basically need two pieces of equipment. You need an RF generator, of course, that makes your RF test signal as you put it into the antenna connector. The second piece of equipment that you need is a SINAD meter that you connect to the speaker output of your receiver. So what you do is you gradually bring up the RF level going into the antenna, and as you do that, you're listening on the speaker. At what point you start to hear your always 1 kilohertz test tone from the speaker, and the point you are shooting for is the point where the speaker output shows 12 dB silent. So the 1 kilohertz tone is 12 dB higher than the noise. So the lower is the noise, just the static is the thermal noise of the receiver, and then your test signal is the 1 kilohertz tone. But by ear, oh, it's really dark, we can't really see it.
You can turn that light up. Hit the button and some more.
By ear, I mean, I can't tell what's 12 dB. So, so what I made was a cyanide meter that I'm going to try to demo here. Here's the meter. Go like that. That's the meter. 1.9 volt battery. The cool thing with 1.9 volt battery is the meter itself is completely loaded. So you can hook it up to any device,
It doesn't matter if the speaker output is single-ended or differential. You're not going to burn out the speaker fiber. So that's why it's nice to have a battery. So this design ad meter, the indication is on this 1 milliamp meter there. You see 12 dB sign ad corresponds to 0.56 milliamp on the scale. Let me put the mic down and I'll hook it up quick. I'll try to find the same audio into my meter and into our system here. Go. Let's see what happens. Okay, I'm using iPhone phone app just to make the sound. Let's see. Not coming out. Okay, full scale. So we're not getting the audio from the. There we are. So that's my test is from the receiver, and you see that it's showing full scale, meaning it is all noise. There's no signal. Now I added sine wave in there. It's showing, I think I'm getting 20 dB sine ad right now. It's indicating 20 dB. No, I'm getting all 10. The indication is 0.64 milliamps. I'm trying to increase the tone level like that. So now we're getting, I think I'm shooting for the 20 dB sine ad, about 0.28 milliamps. Anyways, that's the meter. Sine meter allows me to test sensitivity of receivers together with RF signal generator. I can demo more. It's kind of cool to play with that. That's it.
Everybody find that tendency? 12 dB, is that the voltage or power level? dB.
That is it's 12 dB. It's 12 dB. I say it's voltage. And why it's 12? The definition comes from the fact that at that point the RMS voltage of the sine wave is 4 times the RMS of the noise. So for this 6 dB in power, but 12 dB twice that, 12 dB in voltage. So yeah, it's on voltage. And that we actually quick point how that meter measures that. It's an AGC circuit that makes the max level always the same, and then the notch circuit that takes out the entire tone, and then the meter actually shows the remaining. So it's showing the power of the noise relative to the tone. That's it.
Okay, thank you. Paul, are you ready? Paul, K and 6HBY? Or is that one that canceled out? No, Paul? Or is he on Zoom? Oh, that's right. I just didn't get it off my list. There's probably a couple more here. Oh, yes, there is. Okay, Bo, are you ready, or you want me to go on to the next person? Oh, okay, how about Justin? There we go. Justin's up. AI6YM. Hello, Justin.
Really exciting to see everybody's progress and their ideas and such. See if I can get this under the camera. Focus.
Oh, let me switch it over. Sorry.
All right, yeah, very much work in progress. Literally held together, but
So, if you want to lift it up, you can loosen the boom. Then just go up, and then you may have to refocus again. There you go. Oh, go back to there we go. We used to have flashlights to hold under the lights here, so at least I got something there.
All right, there we go. So this is a 10-band HF rig built around a PAARA one. That's an SDR kit that can transmit and receive. And sort of my motivation here is I wanted to be able to cover in a band. I wanted to any mode that I wanted to. Some really interesting things you can do with SDRs you can't do with traditional radios. Zero bandwidth modulation. Hacker F1 can do a 20 megahertz wide band. So with a little bit of software, I could do every single digital mode from 160 meters to 15, I think, all at once. The problem is Hacker F1 is, and most SDRs are really bad transmitters. They're kind of really bad at everything because they're built to do anything. You can do 1 megahertz to 60 gigahertz, does all of it kind of bad. You don't really know what the spurious emissions are. You get about 20 milliamps of output power, which is not really enough to make it to my driveway, much less anywhere else. And I like URP. I like playing with low power, but that's excessive. And there's not really any amps on the market that can cover 20 milliamps and bring it up to something reasonable. So this is basically the rest of the radio for a half RF or for some other kind of SDR kit. Mostly built around kits. A lot of this is QRP Labs kits that are being used in ways that they probably were not to use. So basically, we start with an amplifier here. We do about 10 watts, and it's mostly what comes in the kit, modified a little bit to handle the lower input. Probably get 5 to 8 watts out of it because it was expecting closer to a watt, half a watt of input. But we need to knock down the spurious emissions we don't know about, and we need a low pass filter array output. So that's what these two arrays here are. The 10 band pass filter array, you can see one of them's missing. Was not functional, have to rebuild it. So I have a band pass filter tuned to every one of those 10 bands, and low pass filter tuned to every one. That's actually kind of hiding under the top layer there. These are relay switch filter kits, and I added an extra one because there's not a microcontroller world that can drive 4 relays at once. So I added an extra layer so that from one single microcontroller pin, we can switch between any of them. And that's basically all we're doing here. I've got 5 control pins for switching any of the relays in the bank. An extra relay here does bank switching. So 10 to 20 meters is bank 0, and the rest is bank 1. We basically select any filter combination we want, turn the band pass filters on or off. So most of the time, we don't need it. Spurious emissions aren't too bad, but when you get around 17 meters on the half RF, you get some really weird noise that you have to knock out. And it's also kind of bad at out of band signals. If you have something really strong nearby, a lot of SDRs like to just make multiple harmonics of their big band frequency. So you can just knock all of it out and have an SDR run on any band with about 10 watts of power. Whatever we want.
Questions? If anybody has a question on Zoom, I'm going to try to watch the chat and put all your questions there. And hopefully I'll get those answered. If I don't respond to you, just scream out and then mute your mic again so we don't hear any background noise.
Quick question here. So you mentioned you have the band pass filters and the low pass filters. On the band pass filters, do you cascade those for DX, or did you put the band pass filters there specifically for the RX side?
So I did them for both. On the TX side, it's always enabled. So you're only getting 20 milliamps or 20 milliwatt power out of the SDR. So the band pass filters can handle it.
Oh, it's bandpass are between the SDR and the PM.
Yeah, so your signal chain here is my Path 1 SDR will be here. It goes into a couple of RF switches. They're buried under my message wiring here. And those bypass the bandpass filter array or enable it. So in receive mode, they're off by default. And then if I have some nearby signal that's a problem, then I'll turn them on. In TX, whichever that they're always on, because I don't know what's random noise the SDR is going to make. So that knocks it out before it goes into the amplifier. And then I don't have to knock it out when it's 10 watts out of the amplifier. So yeah, we go from the SDR through a switch into the bandpass filter right here. Whichever band is being transmitted, that's the relay that's behind. And then that goes into the amplifier. Output of the amplifier comes into the LPF array, which is under the switchboard. Same relay and bank will be hot, and that comes out of the antenna. And just for grins, because I like making mistakes, but not mistakes that cause me to lose hardware, I kept an overvoltage breaker, an overvoltage over amperage breaker there. And that's part of why this is helping take the fluids. I intend to take this apart and do a lot of fixes with it. I learned best from my mistakes, so I try and make as many as possible. But I don't like having to rebuild everything.
Thank you. Okay. Andy's up next, so since he's got the whole table here, we're gonna switch cameras, and I don't know about light, we'll try our best to get that lit up for you. Thank you so much.
Yeah.
See what? Oh,
Okay, so this is a finding. Hope to make a network.
get closer to your mic there, Andy. Your mouth.
I had it around, and here was the area, oh, okay. And so, it uses the Raspberry Pi 3 B,
Switch that.
which is just barely fast enough to do the job. Oh, I guess that could hold. And a few years ago, I started out with this rated direction finder, upper direction finder, by Ramsey Electronics, no longer available. So I built an interface card, and that goes into a Raspberry Pi 2B that I first started with. Then I was going to use these nodes, these kind of units, but they became unavailable. Some hands call it unobtainium. So, anyway, yeah, there's another Red 2B, but not using it anymore because I decided, well, to develop RDF network, we need to have something that's obtainable. And so I started with Pi 3, but now some friends are telling me, well, you go up to Raspberry Pi 4 and 5 now is really super, very fast, but it draw more current. The 3B is good enough for me. Okay, now here's what I can show you how the thing works, but I can't really make it live because I've got to bring power with the scanner receiver, and I was going to show you how when you click on the instantaneous repeater, that all of a sudden you can pick up the chunks down to 1/20th of a second. So anyway, here's some short. Here's some wrong transitions. This is a short chunk. This is Audacity software that's playing back and captured with actually the raw data file. And here's a spreadsheet with Open Office or Office Lever. Anyway, this shows how the bearing's stable, but not. I'm still working on it. See these little glitches here? Well, I'm trying to figure them out. But anyway, so here's no signal and here's signal. When there is a good signal, and I have a couple of quality factors. One drops down when the signal's bad, goes over, and the other one also goes up. So, we can send to the website of the K, RDA, KN5R, that's Robin Shawtime, .net. But, I can't turn right now because, I can't power up this system. I forgot to put something. Anyway, so this is the downward direction finding antenna where you switch between 4 and 10 very fast, which we were switching about, about 21 milliseconds. I can't remember. No, a microsecond. So we're doing 1600 hertz. Boom. And here's this the program is pumping out 20 times per second, battery. It's going up. I couldn't figure out how to get Microsoft Windows 11 on this laptop to send to the website. I'll figure it out sometime. But that's where time is a good job of it. Well, very good. Unfortunately, I only have the Ethernet. I haven't figured out how to use the Wi-Fi here. Does a 3D have Wi-Fi?
Yes, sir. Built in.
Yeah, I just gotta learn how to use it. Okay, well, anyway, what else can I show you here? I guess it's about, yeah,
We got time for questions there.
The network is out there, tell us about that, a network, I'm sorry. There was a network of these, radio direction finding, devices out there, or are you trying to set up a group of people to build these?
we have some hand volunteers who have our skills, who are willing to install. But I gotta get the software cleaned up first, get it to work right. The bearing kind of shakes a little bit still.
As we all do.
Yeah.
Okay, I'm looking here on Zoom, making sure there's nobody in chat for the question. Thank you, Andy. Quite the project. Thank you for sharing.
Forgot to add something. The whole idea is to come up with something inexpensive. Turns out the Raspberry Pi 3B only costs like $50 or less. In fact, that there's an even cheaper one, 3K62. Well, keep also, there's a $10 one, I think, Raspberry Pi W2 or something like that. So, and it also has 4 cores. Oh yeah, I forgot to mention something important. Can I? Yeah.
Go ahead. You got 3 minutes left.
It's gonna work, for the signal buffer gets divided into 4 parts, and it's running 4 apps, not right now, but it can, running 4 apps in 4 individual cores of the Raspberry Pi. But with the cheaper one, the W2, I can afford to put 2 of those in there. I can have like a 8 cores, and make a even a faster or deeper filters to knock out everything outside the buffer zone. Okay.
Thank you. Okay, before I forget, all the presenters tonight, don't leave when you're done. I need to get a group photo. And because of your time and effort tonight to present, Kara graciously has a little gift for you. So you want to get your gift. And because I made you late on the show, I feel like I want to give it to you as well. Okay, thank you very much. This is the order. Let me know if it works for everybody. David will be up, and Connie, Nick, and Henry. Was there anybody else I left? Oh, and Bo, when you're ready. Was there anybody else that I missed? Oh, let me get you here. Zoom. Okay, I think we're actually catching up here, so no problem. Okay, so then we'll go to David next. There we go. It'll be last if we have time. If you stand behind it, it should be right in the screen. So let me bring it up. There we go. Oh, I'll pin it. Hang on a second. Pin. I believe we got it right this time. Or if you spin it around, there you go. Now, if you come around the table, if it works better for you, so your mind is looking how we're seeing it, I don't.
All right, so, well, it might, doesn't look so dramatic in the camera here, so let me take a moment.
You can tilt it up or whatever you want, and I'll have one of my finest assistants help you.
Here with. Through it to you. And it's a take-home quiz. A very unique device. I'll put it back here. Okay, what is unique about this device? Well, it actually has no microprocessors, no Arduinos, no Raspberry Pis, no transistors. It does have 4 solid-state diodes. This is what may appear to some of you as a vintage novice transmitter. This is actually also a time machine. Now, why is that? That is because I wanted to build one of these when I was like an early teenager. And many of you remember something you wanted to do back in those years, and maybe you for whatever reason never got around to it. And the people in this room, I'm sure, will note that I'm not talking about that coffee hour guy in high school, but rather a radio project. So this is a novice transmitter, 4 tubes right now, built from junk parts from television sets. And I'm sure that those of you in the room whose hair is at least as light as mine will remember 2 television sets, right? And what you would do if you wanted to build one of these was you would find the nearest television repair shop in your neighborhood, because they were always throwing out old televisions. Now, I highly recommend doing something like that. Well, it was recommended to do something like that rather than try to take parts out of your family's working television. And I'll tell you why you know about that after the session. But what this is a design published in this book. This is an ARRL book, Understanding Amateur Radio. And this book actually would tell you how to take apart an old television set and analyze the parts to build something. And so as I mentioned, a little bit younger, maybe 10 years ago or so. And for whatever reason, this didn't happen. But this thing came together in the last few years. And I got it working and got it on the air for Straight P-Night. You know about Straight P-Night. And actually had a lot of fun with it. So I did publish an article in What Radio Magazine, and I'm going to skip over the technical details, but I got the article here if you'd like to take a look, and I'll be hanging around in case you have any questions. So in the interest of time, I'll...
You have 3 minutes, so elaborate if you need to.
How many minutes?
3.
3 minutes. All right, I'll tell you about that gal in the high school that I lost. Sorry?
How many watts out?
How many watts? Well, right now it's about 40 watts. Those of you that are into the vintage television thing will know that these are sweet tubes from a television set. This is the audio output tube of K6 from the television set. This is actually this is an advanced version because it has a voltage regulator tube that gives you a better note, a better CW note. This is CW transmitters. You can hook that modulator to it if you want. That's my next project. So this is the kind of a time machine for it. And kind of a blast from the past. Maybe it brings memories from some of these. Question?
Is that push pull or are they parallel?
Parallel, yes. Yeah. I'll keep it at that for now. I'll be around. Oh, another question. Yeah.
Band is it, or bands with that? So have division.
Bands. So it's basically HF. So the frequency is defined by coils, plug-in coils. And the original design told you how to build coils for what were then HF bands, so 80, 40, 20, 15, 10. Now you could buy new coils for the fork bands as well, so that's how you switch bands on it. So I'd just like to say, stay tuned. I hope to present my next project here in the not distant future, and that will be a different kind of time machine that will bring back that gal that I was thinking about. Thank you so much.
All right, thank you, David. Okay, Connie, you're up. Let's turn that camera a little bit to the left.
Yeah, I'll just bring this up because I think and Mike,
He's got it there. Move it right up, so if you want to lead over, John is there.
this is second.
So, yeah.
Okay, so this is in two parts. My name is Connie, W6EFI. So I have a couple of things to show. I don't know if you remember last year, I brought in a wire and a plug on the end. And said, this is my homebrew antenna. And that works great. You just shove it in the tuner and go. So my point being that you don't have to get too complicated or understand stuff, a lot of complicated stuff to actually get on the air and even build things is pretty easy. Putting a banana plug on the wire was a challenge for me at that time. So this time I have a little more complicated antenna, which is what I'll call the 10-minute, 10-meter dipole. I had, well, not 10 minutes, but maybe 20 minutes to get on some 10-meter net that I had committed to. And so I quickly ran around and found parts to make a dipole. And again, my point is really that it doesn't take a lot to make something that is quite functional, that can be semi-permanent.
That's got to be the most economical and scrapyard holder I've ever seen.
So what I did was I found a junk piece of plastic, a shoebox. Okay, if you don't have a lot of junk in your house yet, you will because you're a ham. But this would have cost, if new, it would have been $2 at Home Depot. I priced it at Home Depot, $2 or $3. But now you got all sorts of plastic for making connectors and center connectors and end insulators. So here is the center connector. The fanciest thing about this is that I happen to have this bulkhead connector, but you can get them cheap on Amazon. A couple of little screws, and the wire is held just by threading it through some holes. So I use scissors, kitchen scissors was the main tool here. Threaded the wire through some holes. Later I added some heat shrink and fancy stuff like print connectors and stuff, but not necessary. The wire is just some old speaker wire that I had lying around from an old stereo that's since been junked. And I just cut it and pulled it apart. It's called zip wire. And that was all there was. That's all there is to do it here, except for these fancy end insulators. Again, just, cut out with kitchen scissors, knocked off the corners so I wouldn't kill anybody with it. And notice I haven't even tied anything. It's just friction. And then I got fancy and put little pieces of paracord so I could tie it to things. And it works great. It's, so that's that. That's the antenna. And the second, all right, so that works. plug in coax, plug it into your radio, it works. Now, it'll work better if it has some kind of a choke. You know, that curly thing, you put it by the antenna, because balance versus unbalance, you can look all that stuff up. Okay, so chokes, look that up. Okay, I knew, you know, better to have a choke. Now, what kind of choke? How do I make a choke? Well, you go out and you look it up, and it's like, it's magic. Here's the magic formula. You need a choke. We're not really sure why, not really sure how. We don't know how to figure it out, but here's some rules of thumb. And I thought, well, it's not magic, it's engineering. Nobody's telling me how to do this. So I said, okay, I am going to measure. I'm going to build one. I'm going to measure. And I did some thinking, and I did some fancy diagramming with fancy pen, my fancy pen computer, namely a big pen. Let's see. And all you need to do, so I've got a nano VNA here, so now we're getting fancy. All you need to do to measure a choke is you want some way of measure the choking on the field of your coax. And so again, I went to my parts drawer, and at this point I had all these banana plug to BNC connectors. That's what I had, you know, and I had these adapters. That's what I had. So in effect, what I'm doing is I'm just measuring the choking of the current on the outside of the coax with the nano DNA, and it's ugly, but it works. If I turn on the nano VNA here and turn this around so you guys can see it and not screw up the connections, I don't know if you can see, but this choke is giving me anywhere between 20 and 30 dB of choking, common mode.
Is that a one-to-one bell? Sorry, is that a one-to-one bell and one?
Well, it isn't, it's a choke. So it's 1-to-1, yeah.
Wonderful.
Yeah, so the idea is that you've heard that, you know, a dipole is balanced, it's the same on both sides. Coax is asymmetric, so it's unbalanced, which means you can wind up with unwanted coupling and stuff, because the outside of the shield is a third conductor. You want to choke all of that off. That's what this thing is doing, and that's what I'm measuring here. So this is this turns out to be a very broad band, works on all the ham bands, and I just did it with this janky junk from my junk drawer. I have since upped my game, but I just wanted to show again, you don't need a lot of fancy tools. There's no soldering involved here. The fanciest tool is the nano VNA, which I think has been a fantastic addition to my kit. And you know, people looked at this and they sneered and they said, wow, that's going to have a lot of parasitics and spurious stuff. And, you know, it does, but I've upped my game. I have a better fixture now. But when I compare my better fixture to this got me 95% of the way there. So that's kind of me, the janky ham, the 95% ham. So anyway, that's my show and tell. Thanks. This is
Okay. Any questions real quick in the audience or on Zoom? I haven't seen anybody chat there on Zoom for a question. Thank you so much, Connie.
You got keeping Anchor Electronics very good. Yeah. See. Oh yeah, that's like commenting on Connie's parts there. I think I recognize about half of those. And I'm glad to say we are keeping one of the paragraphs advertisers, Anchor Electronics, well in business. That's between me and Colin.
All right, Nick, you're up.
Sorry, it's Nick, N6008. And what did I build? I built a 17 meter. Can you see this over there?
We'll turn the camera that way.
Turn around. Block of people. Bring it up on it.
Yeah, go ahead, and then we can just turn the lights a little bit. I think we can see it on Zoom still.
All right. Sure. Right here.
Yeah, that works.
All right. So this is a 17 meter magnetic loop, and underneath this cover here is a 5 kilovolt vacuum variable capacitor. I'm running about 10 to 15 watts on the electrode here. And at that voltage, I mean, at this wattage, there's about 425 volts as a capacitor. Hey, encapsulated there, those storage when you get something like that. But I like going out to the park and just hitting this up on the bench because I'm lazy. I don't want to put wire. You know, it's easy to throw it in the park. It does tune from 10 megahertz to 30 megahertz. So they'll pretty much cover from 20 meters all the way up to 10 meters. And it's pretty sharp tuning. And it's pretty high Q for those that know what that means. So basically, if I touch the antenna now to see if you can hear it decouple, so it's pretty high Q. So it is a really sharp tune, but I've worked in Japan, I've worked the Philippines, Hawaii, Alaska, just the 5 and 10 watts. It's pretty fun. And the good thing about, I'll make it short. The good thing about loop antennas where I live is there's a lot of noise to 1,000 feet from the Valley Fair Mall. So this reduces the noise by probably 25, 30 dB. That's it. They're fun to build. No, the height doesn't really matter on this. 3 to 4 feet off the ground. People actually use them horizontal too, and they do some different things. But they're pretty fun. If you bring another loop close to it, I have another one. You can actually couple the two. So I can tune here without it having, and it'll tune this transmitter. So they're parasitically coupled. So they're pretty cool. This can swivel. If I loosen this case here, you can, and of course, their direction off the ends here. And let's see, lastly, there's a little meter at the top here. When I key the transmitter, I can see maximum power. On this, it's at minimum SWR here. So I can get a pretty much flat match. Anyway, that's it. I'd like to hear.
Good question.
Sure.
I was wondering, what kind of a financial investment is this for the whole setup?
Well, I think I got the capacitors for free. I still have a bunch. Someone needs some capacitors. They were given to me, and I was told not to sell them because it came out of a sputtering machine from Lamb Research. So I took a few and I gave some to some friends. Actually, I have the large ones, 20 kilowatts. And it's in there, I think 5 to 50 picofarad or something like that. But they work great for this. I don't like to use open air capacitors because there's a lot of losses there. But the total investment in here minus the electrode, I think is probably less than $100. I'm actually much cheaper than that. 65.
Got a question. Where's our microphone guy? Oh, there you go. Soren's up here.
Great, neat looking device. Can you tell us a little bit about the tripod that you're using to provide that, and what was your source, and also a little bit about the mechanical design, and maybe a little more about those.
Okay,
a little
so
bit about this metering circuit. You have a diode.
just the diode is very close to the top here. Capacitor with voltage is very high, and it's about as basic as you can get. There's no pad in here or anything. At full scale, it'll at 20 or 10 watts, they'll peg the meter. The material here is glass, fiberglass here, little boom. This is also fiberglass with rod, the tuning rod, so just to keep from coupling. The primary loop here is just a piece of copper, and it's just tight, and it goes through the fiberglass and goes into the radio here. Let's see what else. The microphone I modified, and it does the full duplex. So if you're talking, somebody can hear yourself monitor through the earpiece, which is really nice, especially if it's noisy. What else can I say? Oh, the tripod. I built the tripod and have a machine shop. It's a pretty much a copy of something else I saw, but I just made a couple hubs and drilled them out. And these are aluminum rods, direct feet on there. I got some feet from like, I think they were from a steeple. And it's just sits on the table pretty nice. I even the house for lifting the short range. Right, Andy?
You don't think that the high voltage danger signs?
No, because you can't really get your hand up there, and you can't get a shock if you touch it here. But if you were to contact we'll still take 100 watts. At 100 watts, it'll put 4,000 volts at the top of the capacitor, so. But it'll handle it because of the size of the capacitor.
But will you?
I won't handle them now, that's probably throw me across the room, so. So that's pretty much it.
Someone has a question.
Oh, sorry, go ahead. And believe it or not, I use a waste paper bucket. I just drank it so it looked pretty sharp, wasn't nothing fancy.
Yeah, let me just repeat the question. It was, how did you bend the tubing? And it was a bucket you were saying.
Yeah, it's really soft copper, and you can bend it a couple times without it hardening on you. I mean, basically, it's pretty much pretty much. Yeah.
And is there a conductor inside?
No, conductor. This is tied to one side of the capacitor. This is to the other side of the capacitor.
Okay, so it's not a shielded.
It's not a shielded loop. That's correct. Shielded loops are great for receiving, especially for receiving. But they take some funky impedance. You need almost an amplifier for it. Shielded loops are nice, but not really good. Any other questions? Okay.
Thank you, Nick. Yeah. Part that you guys never like go to County Com. He's the man right there. All right, Henry, do you mind if I have Kazu go in front of you and then Bo? Apparently, their pop may coincide with each other, so no problem. Kazu? Yep. All right. Oh, thank you. What do you guys need to go over here? Yep. Okay, there you go. Don't step. There you go. Set my clock again.
Hello. So my name is Dr. 86 NS, and I'm Rob of 86. I'm wrong. So I am showing the really big thing. Is this? This is the board I developed, and this is the open hardware, open software. So I opened all the CAD file, everything. And we are from SF Hub, which is the San Francisco Bay Area high altitude balloon group. So we are launching the and this board, this tiny board, it is actually the beacon. So this is a 20-meter whisper beacon with 2-meter API. Tiny.
Perfect.
Yeah, sorry, too tiny. So this one has the GPS module here. And this is the MCU, which is the Raspberry Pi RP2040. It has a 2-core. And so this tiny chip is a BF4 chip, which is the frequency synthesizer, is size 56, no, 53, 51. So basically, this MCU controls this BF4 and generate a whisper signal. And this GPS receive the coordinate and transmit the coordinate information and altitude information through the whisper signal. And one of my balloon is still flying since October, and it's already done 17 circumnavigation and it's still flying. Yeah. So, so we use a hydrogen. This is very easy.
Oh, thank you.
And probably I should show this one. So when you play the movie, so this is how we. How we launch the balloon.
Hiroki, was that your equipment making the noise still? Oh, we're getting some interference. Just wondering where it's coming from. Oh, it was before the cell phone, but that's okay. Go ahead with your video.
Okay, so basically this is how we launch the balloon, and it's flying or it's increased the altitude very slowly, probably 1 meter per second, and it goes up to the 13 kilometer or 14 kilometer, and flying around 30, between 30 to 14 kilometers, for about 45,000 feet.
Question?
Yes.
You have to have a special FAA permit to use hydrogen?
No.
Because is that considered dangerous? You think?
FAA 101, FAR 101 is the federal regulations for all air use for everybody. And there's a section for free ballooning, and they don't care about what lift gas you use.
So, so because the Pico balloon is flying for a long time, and so we went and made this tractor. So we call this tractor. Tractor make it very light, so less than 3 grams, and with the solar panel, with 20 meter than vertical dipole, total weight is around 10 grams. And free lift is
6 grams to 8 grams, yeah.
Yeah, 6 to 8 the free lift. So we are launching the component every 2 weeks. Usually from Berkeley Arena,
Or Evelyn Park and Milk Pizzas. Evelyn Park and Milk Pizzas.
Yep. So if you are interested in police community, and so we are SF dash FHAD SF dash HAD.org. So please check that website.
Cost.
Cost. Okay, so I ordered this in a JLC PCB, where is the famous PCB manufacturer. So I just submit all the Gerber file, pick and place, and bomb file, and I ordered 10 of them with assembly service. So that means they mount all the assembly parts for me. And the total cost is around $130. So divided by 10 is $13. Yeah, and this is an open source open hardware project. So everything is open. So our intention is this is for the STEM educational purpose. So I hope this my design will be used in high school STEM education. Yep. Any questions?
You said, about 45,000 feet?
Hey Doug, real quick, I have to reset Zoom if they ask. Go ahead. You're okay, keep
So
going.
how are you getting clearance for that? It's not like a trip up and a trip down, you're just like,
Circumnavigating. No regular, the FAA is fine with that.
even the flight levels?
So we're typically flying between 30 and 40,000 feet. And, there's, there's not much traffic out there. Most of the air traffic is well below 40,000 feet.
Yeah.
Well below, probably 30,000 feet.
Alright,
Or low 30s. Yeah.
do they keep tracking you and like keep you on the,
Yeah, this is-
nodes or anything?
So if we do a full high altitude balloon, we will file a node cam for that. But for the eco balloons, we're talking about, the 10-gram payload. They test aircraft engines by tossing turkeys into them. So, they have to withstand that, full traffic.
I'm used to way more aviation regulations, it's cool that there's a little carve out where there's none.
This is FAA, 101, FAA. You have a section, and nothing about circumnavigation until you come down. Oh, okay, so.
Well, I think one more question.
I'm gonna Dave, you have all it after. How many days? Just two. 181 days. Wow. I've never counted. I'm not looking at this for 2 years. 2 years. I'd just like to mention that we have a lot of projects and we need more hands. So if you're interested in building stuff, please join us. We got lots of people.
Yeah, sf-had.org.
What is the advantage of hydrogen over helium?
Okay, so hydrogen is cheaper, and up until recently, it was way more. Helium has finally become available. For a while, you couldn't buy it, and so hydrogen is cheaper. It has a little bit more advantage with lift, and it has a little bit more advantage with not escaping the plastic. Okay.
Okay, thank you, guys. And Bo, K6PAU?
Yeah.
And Ricky, say your call sign again, sorry.
Ricky, KN6KZ.
Yeah.
Yeah, why don't you talk a little bit about radio systems for me while I
All right, I'll talk about reusing.
Start with what this thing is and then I'll.
Well, do you want to start with the radio song? Or with how we track the radio song?
How many people have seen one of these?
All right.
Well,
So for those of you who have not been following Bo's adventures in radio, this is the ultimate treasure for a hand amateur. These go up every day, twice a day, from a boatload of places all over the world, and they're usually hanging from about 100 feet of string on the other end of the show you the said remnants of the first latex balloon here. But the interesting stuff is what's inside this little package, because this is where we get most of the atmospheric weather telemetry from. So the radio sonde inside here collects atmospheric data on the way up, pressure, temperature, and the location of the oscillatory speed.
and so if anybody ever finds one of these,
They conveniently are peaking and transmitting in this area on 404 megahertz. And I'm going to show you an app that you can just take a Valfin or any HD or any old radio or SDR dongle, tune it to 404 megahertz. And you can hear these beats. So I happen to have Valfin and tune it in here to 404. And also, if you find one of these, it's actually a power button. So you can turn these on, and now I've turned it on. And that's the sound of a weather balloon. And you know you found it because it has a very predictable 1 hertz cycle.
Also know we found it because we're close enough to pick it up on a bow thing with no antenna. That's where the sport comes in. So we will drive around first with the antenna on, then with the antenna off, and a little wet noodle on there, and finally no antenna at all, and then you're within 50 feet of it.
Oh, hey, we have another mic here. How convenient. Okay, thank you. So, and I might be double booking here. I have a presentation on one radio songs, which we haven't gotten to yet, and Ricky is doing her presentation on other radio songs. So that's my excuse if you allow me to go over time here. But nonetheless, so you can download this app. We go to the overhead. And so what you see here is this little device here you can get for $30-ish. It's an ESP32 wireless piece of hardware that also has LoRa. LoRa in this country typically runs around 915 megahertz. However, it's a very flexible radio. So some fantastic Italian hams, honorary QSVers, that are definitely hams that pack. Shout out to come join us any given first Monday or third Friday of the month, around about 1, 2, 3, 4 o'clock. Find myself, W6REK, the likes of Connie, this one, sometimes others, hanging out at the picnic tables in downtown Mountain View for lunch and playing with stuff like this. But back to the show, here's my Android phone running this My Sondigo app, which pairs with the custom firmware running this device. So here I have it tuned to 404 megahertz, and it's great because these devices communicate with each other over Bluetooth. That's one of the features of using the ESP32 device inside this other piece of hardware. And so I'm able to actually program this radio using this app. So here I've tuned to 404 megahertz, and I'm getting this green blink which says it's getting reception. And it's hearing a thing. And so here it's decoded Victor 4340050.
And I can confirm that the serial number on that song is Victor 4345050.
Fantastic. And it also gives you altitude. It'll tell you how far you are from it. It's saying we're up over here, and it's currently saying our radio songs is time traveling in a multi-dimensional space and currently out in the Pacific. That's part of what this red light is. Obviously, I'm not getting a good GPS signal here, so I'm getting some bogus data. But when you're tracking, it's really cool because you see this updating in real time. You can switch from straight view to satellite view. Rob has some experience with this. We've run into each other a couple of times on Chase. And also you can see this little device is drawing walking 0.05 amps at 5 volts. So very low power, very convenient, very portable, easy to go on the run. Using the same antenna with the connector that I use on the HP. And thanks to Andy and something a little more convenient than the cutoff blade tube, we do body fitting. So we'll start with the antenna, and we'll be stopping in the middle of the road. I'll be jumping out of the car with the bright orange vest on, and I'll be swinging around a giant Yagi. You'll see this driving down Middlefield on occasion, trying to hone in on it, and then I'll switch to the antenna, and we're doing the same thing. And then take the antenna off, and we go with the wet finger distance signal. And very carefully press your wet finger to where the antenna goes, and do not press the transmit button. Ask me why. You won't have to. And then we get into dry finger range, and then we get into no finger range, and it's going to basically be within the row of this front row. Anything else?
Well, I think it's time to move on to the homebrew.
Isn't it? Yeah, I actually gave you some stories about how we collected these radio songs. And we are gonna start with this one, which conveniently there was all this hardware on the back shelf, and I didn't bring one of my wires. This contraption here is a radio sawn taped to a breadboard so that I can make a slight adaptation here to get this serial dongle, which has the wrong headers. So we're going to go on to the chase here, and now I'm going to talk about what it's like to actually recover this. So whenever possible, I will be on the N6 NFI repeater and talking to folks. Yeah, we're going to actually switch my monitor here. As soon as I find the share again. And thank you all for setting up this Zoom. I really appreciate being able to come to some of these meetings remotely and also being able to integrate my presentation. So this is the story about how I found this. Would you turn that one off? And this is now Victor 1920461, which you'll see I entered in the search up here. This is a fantastic site, sondayhub.org. I started a couple other projects currently supported by ARDC and others. But this is a great tracking site. It'll give you real-time telemetry, and twice a day, you'll see hundreds of balloons in the air at the same time. And it's this whole project where there are Raspberry Pi SDR receivers all over the world submitting data to this. And NASA, or the weather agencies, are just tracking it up to get a vertical slice from ground level to about 120,000 feet, but we're all tracking it all the way back down as well. So here you can see all the Raspberry Pi SDR decoded data. You can see that it's going up, it's coming down. This is how many satellites it's got. This is the battery level. We're getting temperature, we're getting pressure. It's funny to watch the temperature go down, 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 and the temperature goes up, even though you're getting higher and higher. But more on that another time. Let's get on to the chase. So I live in the East Bay, and anytime there's a balloon that's going to land within 10, 20 miles, I'm generally going for it. And so on this given day last year, it was heading for some of the hills in Oakland. And that's pretty convenient for me. And here you'll see the whole track. So this is the Oakland Airport. This literally launches from Oakland Airport runway. And then I actually have an antenna on a roof down here at Packer Dojo that is often getting a lot of this telemetry, as well as other stations. That green line is the last station that saw this particular. So anyways, I'm driving over here toward Berkeley, and this thing is up near a golf course. So I've got a rough idea of where it is. I'm DFing to it. The last altitude recorded, sometimes people cut out around 3,000 feet. But here, this came down to about 1,000 foot of altitude on a hill, so it's pretty close to this area. So I'm driving right up this hill, it starts beating, coming around the bend, and I can hear it on my HT. And I chase and I chase and I chase, and I get up here, and I'm DFing, I'm all over the place. Like, it is definitely landed in the golf course, right on the other side of this annoying fence. And so I drive over here to the parking lot, jump out of the car, I'm now a golfer. I'm roaming around the fairway, and I'm DFing this thing. I've got a signal, so it's over here, it's over there, it's over here, it's over there. It's somewhere. And let me switch to my slideshow portion. And okay, so now I'm in the middle of the golf course. You saw where it was. Now I'm in the middle of the golf course, actually looking north. And I'm DFing this thing from all places, the driving range. And I'm like, okay, it's right out there in the middle of the driving range. That's gonna be fun. But no, wait. Isn't it over there? Like a reflection off the hill? What in the world is going on? I would swear it's like right there. And it's supposed to be right over there. But if I'm in a reflection, it might be right over there. This darn thing is just being weird. But I know I'm close. So now I walk down the hill and I'm getting wait a minute, it's parallel to the driving range. It's right there. What? I don't know what's going on. So I keep going down there. I walk down the path. There's a golf cart running around the corner. I take the antenna off. I wet noodle it. I'm fingerless. I'm getting close. I'm walking around. it's in the freaking golf cart. I was standing halfway around the back nine, and we met each other at one of the tees, and I'm like, who'd have thunk it? So that's just one of the totally random things. Okay, I'm gonna try to place through even better version of this story, which is this photo. One of my top 3 all-time finds, absolutely for sure. Why? Well, let me tell you. It was somewhere over by Lake Chabot. So I pull up on the road next to the park, I get it out, I DF it, I'm like, this is that one. Well, surely it didn't land in the water, because if it landed in the water, these things are, it's just foam. There's no coating, there's no waterproofing, it's just a fair circuit board, a couple of lithium batteries, which if anybody's struck lithium in the water. So nonetheless, I roll up, I park on the road, and there's a marina down. And so I come down to the marina. Guess what they have? Lake Chabot boat rentals. So, reservoirs, apparently, you're not supposed to swim. It's okay for fish to do whatever they do, but humans, doesn't matter how many showers you do. But they have boats. So I walk in, boat rental. Kayaks, I was thinking I'm gonna get one of those pedal boats, whatever. But heck yeah, I'm doing a standard electric. Only debate, do I need an hour? Do I need 2 hours? Or all for a day? Let's find out. So we pick one out. It's got these they're really hackable, nice batteries. They've got Bluetooth, lithium ion, real-time stats, how many watts you use. And we set off. Oh yeah, it's totally threatening to rain. That's been water we can get it covered. I mean, what could possibly go wrong? Like, surely, head to toe electronics, flip flops, chasing a balloon. What, you know where this goes? Yeah. So, let me see if my audio is working. Oh, I don't know if you guys are gonna be able to hear this in and out of the room. Uh, Background on this, it's in part.
Still transmitting.
Yeah, so wild, when these things hit the water, they turn into like bubbles. And this is the antenna. And this is the 200-foot vapor line with the latex balloon that's feet to the bottom of the plate. And so it keeps keeping. And then you hit the power button. Eventually, when I figured out how to push the button, it stops heating. So yeah, K1OKS, if you remember, you were along for the ride on that one as well. So yeah, that was all the fun to be had. And yeah, made for an amazing rest of my day. What you find on these things? Harmless weather instrument. Thank you, National Weather Service. And also, even better, the finer detail said, don't send it back to us. We don't want it. So yeah, it's like, oh, this is my lithium ion battery powered victory spin heading back to the marina because I still have like 20 minutes left on my rental. So I was doing that snips to yeah, Andy. Yeah.
Was it floating on its side in the water or standing up?
I've seen both. I recovered one in a freshwater creek that was just laying there. But here you can see it. So it's sitting there.
This way.
Yeah, it was both just like that. I had another one that was actually pulled down, and so it was kind of bobbing like this. But yeah, this one was just so delicately, perfectly sitting there, waiting for me to come and scoop it away. And then also, I feel like I did my due diligence of pulling 200 feet of line latex out of the reservoir and taking it home. So if anybody finds a harmless weather instrument, drop a dime, give me a call. I'll help you recover it. I'm sorry to say that I was totally unprepared for this, and oh no, error.
And you're gonna need to wind it up here soon, but
Yep. So now, I actually, as quickly as conceivable, want to get to the actual homebrew portion of this talk, and fire up my putty here, and hopefully, of course, because live demos always go so fantastically well. I'm going to turn on my other device. Oh, and we see it talking to us in multiple modes. And so here, this is actually my hack, this thing duct tape to the breadboard, which is on the back of this, there's an expansion slot. There's a 2x5 header with 10 pins. That's a UART serial and a programming interface, a battery connector, and a couple of other fun things. So a bunch of us have been hacking on these things and reverse engineering. Plug it in with just a receive line over 9600 baud, and you turn it on, you'll get this lovely dump. Australia RS41 radio song, software version 2.2.15, upgraded by Australia. 2016, this has been flying for a while. It'll give you the serial number, it's also got an additional pressure. It'll tell you what frequency on, and it's tell you how much power it's in. That's 0 of 7, as in starting index at 0. So that's the lowest power transmission table. Obviously, we can hear it. So the whole point and fun of all of this, if oh, I'm not connected. If we can go back to the overhead for just a moment. So device reboot.
you're sharing still, I think.
Okay, yeah, that's good because I'm still rebooting. But yeah, okay. So I'm gonna stop sharing.
No audio for the Zoom people.
So I need to share again.
Yeah, we can hear you now.
And yeah, you need the overhead camera when you're ready.
I gotta get out this pin. Hang on a second.
Yeah, you can.
You need to click the start video first after disconnect.
Oh, thank you.
There you go. Probably the full cat. So you got the overhead here. No, this is perfect. I can see timer. Okay, so now what we're looking at is we're connected up, and I'm still, I think, share. Can we get the co-host or screen sharing?
Doug, are you able to get in post on? Oh, okay, gotcha. Thanks.
So what I'm the whole point of this talk is actually very long-winded explanation of all the fun things that radio songs are and all the fun times that I have chasing them. But the whole point of the homebrew tonight is I've collected some of these devices, and through that back port, you can actually reflash the firmware. There's some open source firmware that's been developed now. Let me turn these into CW and run them on UHF amateur frequencies. So you can actually repurpose the transmitters. It's a little annoying. You gotta like crack these things open. You gotta have the right little programming hardware. It's not too hard. It's not too expensive. You can totally learn how to do it in an afternoon. But the thing that I found I want to share with you tonight is you don't need anything more than a 99-cent UART connection, and any microcontroller will do it. And you can actually connect to these devices, and you can change the frequency and the parameters, and dump all kinds of information out of this. So if you can't do the share, I can point that overhead at the screen here, and this might be close enough to demonstrate at this point. So what I'm going to do is I'm going to go over to Putty. If yeah, okay, it's somewhat legible. I'll talk you through what's going on here. So now I'm connected to the device, and I'm getting that same printout thing. And if I hit the keyboard, I actually have the receive and the transmit connected. Nothing's happening. If I type in the magic undocumented sequence, I drop into a service menu. And now I can do things like show me all your sensors, and it's taking out humidities, temperatures, and I get parameters, transmitters. And so I've actually already got a little hack in here. You notice this is no longer the actual serial number. It says X-ray 1337 Alpha Bravo Charlie. And if you guys pull out your radios, decoded it, that's what it would actually be saying to you. And now over the serial, if I hit I can say X. And now when I hit enter, it's going to start transmitting. Beep, beep, beep. Boop, it went boop. I got a new radio song. Now it's called Hacks. And so you can also use the thank you. Yes, that was the paper deal. You can trivially reprogram these at 9,600 baht to do any 8 characters that you want. So thank you all for the extended show, and I'll publish more info, and please bug me about this another time. I haven't already put it to sleep. Who do we have?
Just Henry left, I think.
Just Henry. Okay. You want to start? You want a demo over there? Do you have a mic yet? You want to take this mic? You got a mic.
All right. Thank you, Bo and Ricky.
Hey, I'm Henry.
You may have to.
W6REK. I have a harmless musical instrument. I've made my own modular synthesizer. Usually a modular synthesizer. I'm talking about old analog equipment, back in the 60s, the Vogues. It would be like over $100 a module to put these modules together and build your own. So I've designed my own circuit board. Each module, there's 6 of them sitting out here. I'm only using 4 at the moment. Has an AT Tiny 85 microcontroller. Those are under $2 single quantity. Making the circuit boards is about $2 after you've amortized over a handful of them. And there's maybe another dollar or two of parts stuck onto it. So it's not a radio, but it is oscillators and it is DSP and a good chance for me to refine my skills as an electrical engineer. So if you look at the top curve, the yellow curve on the oscilloscope, you can see it looks like a frequency modulated sine wave, and that's what it is. You're looking there at the output of a voltage controlled oscillator that outputs a sine wave. And because it's voltage controlled, there's a voltage coming in that determines what the frequency is going to be. Well, it's coming out of a low frequency oscillator, which is a triangle wave, and that's being modulated by another low frequency modulator, which is a sine wave. You end up getting a kind of a chaotic sound there. And you can turn these knobs. So it's got blinking lights, it's got knobs, it makes noise, and it's patchable. Instead of expensive banana cables, I just have these little headers sticking up on each one. And you can patch the headers to give the inputs to the modules and the outputs to the modules. And that makes it real affordable. So some of you might have seen previously I did it on breadboard, but these breadboards wear out after a while and your connections are not too good. So the connections have actually been a lot better on these circuit boards. And I'll be designing another generation after I figure out what I like and don't like about the way I did this one. Oh, and then the final module it's going through is an echo module. And it gets a lot of weird aliasing in there too. Okay, that's it.
Thank you, everybody. I think that's it. No other. And it's 9.
So many good presentations tonight. This is the best I've ever been to for over 9. Thanks, Rob.
Thank you. Well, due to the half-hour debacle at the beginning, we would have been a half hour more. But so obviously, I'm going to have to cut down the rest of the agenda, which mostly is some rehash. But I know Daryl's got some stuff to cover, and so we'll go over some important stuff, and then we'll get out of here. So once again, sorry for all of it. All the presenters, once again, I'm going to need a picture later, so don't head off right away. And if I can get a volunteer to take that picture, that'd be great. So let's continue on with the agenda real quick. Soren, you want to take a mic up to Daryl there, and he's going to talk about Fair in the Park real quick. Oh, you're going to come up here? He's going to come up here.
You did good your first time, Rob.
I got a fan.
You've been expected.
Hey, everybody. Okay, first off, hello.
Thank you for being here.
Okay, great. First of all, let's give Bob a big round of applause.
Thank you.
We run the show and all that. It's you know, Bob, you're doing great.
Thank you.
Okay, so PAARA in the Park is on. You can tell me what day that is. PAARA what day is it? Right, 420. That's right. It's not going to be on Hippie Hill. Okay, so it's going to be at Casino Memorial Park, the picnic area. There's going to be lunch. There's also going to be another activity. We're going to do kids film. This would show up on the bottom here. Okay, this whole concept and idea came from class, right? And so I built this antenna. I built I'll put it all together. The intent activity is gonna be, this is the antenna mounts, and that's what 239 on it. And you see these three wires here, that's up here? That's for the radio. Okay, this is the telescopic 10-foot antenna piece from NFJ. There's actually really sturdy stuff. Anyway, if you're interested, down there on that table, you can pay us $50 and sign up. So, and we'll start the antenna build at 11 o'clock on there in the park. It's a great deal. We're actually taking a bit of a hit on the cost, but $50. So, there in the park. And, let's see. Rob, did you want to skip question of the month? Rob.
I think if, let me just bring it up and you can do it real quick, no problem.
Okay, all right. Okay, any questions on Fair of the Park? No, okay, all right. Next one, who read paragraph and who knows who's Eli the Iceman? Okay, now some of you electrical engineers, you probably know the answer, but those of you who are not electrical engineers, would like to take a try.
I know who he was.
Okay, all right,
I know who he was.
all right, you want to give us an answer?
Yeah, he was Iceman.
Eli, who is
Eli
the Iceman?
Eli the Iceman was a killer, contract killer for the Gambino family.
Oh, killer. Okay, no, not quite. Anybody else? Okay, you electrical engineers, keep me honest. Eli the Iceman isn't really a person, it is a demise. Okay? And it's a way to memorize or remember what devices the inductor or capacitor, whether voltage lead current or whether current leads voltage. Eli, E-L-I, if E is voltage, and L is an inductor, and I is current, so that means voltage leads current. That's Eli. Ice, or ice, yeah, but ice is I is current, C is capacitor, or capacitor, if you will, and E is voltage. So in that device, who leads what? Current leads voltage, or voltage lags current. They either say lead or lags. That's an educational for who Eli the Iceman is. Electrical engineers, did I get it right? I mean, it's a basic, we talked to basics here, right? But do you guys agree? Yep. Okay, great. All right, Rob, anything else? I think that's it. Any other questions? Pair of the Park? Anything else? Okay, great. All right, we'll see you on the 20th. Yeah. Oh, there's a question.
So there in the park, I thought I heard something about donation or fee. What was that?
Whatever you want to do that.
We're not doing donation. If you want to purchase an antenna to be part of the antenna bill, that's $50. Otherwise, show up, have free lunch, and participate, get on the air, socialize, have fun. That answer your question? Okay, great. Okay, Rob, we exactly.
Thank you for all that information. All right, once again, all the items in the back on the far right is just grab a bunch of stuff and you think you got $5, give it to Clark. The stuff that is priced, make sure that you pay up for that. Connie was talking about a little chassis mount SO239. Guess what? I think there's this package of them back there for like $2 or $5 or something. And of course, someone's got to take that FT DX 1200 home tonight. Come on, that's a special deal. You get the power supply and mic free, and it's like the lowest eBay price possible. So someone take that, please. All right, due to the lack of time, I'm going to cut right over to any new hams tonight, real quick? Any new hams in the house? Anybody on Zoom, new hams? Nothing. Any upgrades? No upgrades. All right, any new members? who's, you got a new member in the house? Okay, no new members.
Make one more.
Yeah, go right ahead.
Hey, I just want to mention there's another event coming up. So I'm often hanging out at Packer Dojo in Mountain View, which is right across from Moffett Field. Also, they're doing a program. There's a museum on Moffett Field, and every Saturday in April, they're doing CW from an airplane to the museum and back and forth. And Noisy Kid QFO is looking for help if anybody wants to come and just sit there and provide their license so that they can transmit and run CW back and forth. It's every Saturday for April at Moffett Field at the museum there. And then I wanted to mention Saturday the 13th, the night before the flea market, we'll be going until 4 a.m. when the flea market starts. We'll be having a game night at Hacker Dojo. So if anybody wants to come hang out, talk to me about balloons, radios, play board games, do other things, hang out, and then go to the flea market before the sun comes up, that's what I'll be doing.
Thank you. All right, Rick is not here. He's our club secretary, and he also takes care of membership. If anybody got a card in the mail, it was a reminder to tell you that your membership's delinquent. So if you go over to PAARA.org, there is a renew membership. You can pay on PayPal online, so get that done. All right, unless there's any other more business, I think that's, say what? I don't know if someone could volunteer. We got to volunteer. All right, so I'll make sure that get all our presenters lined up and don't leave, and we'll get a picture. It doesn't have to necessarily be in front of all the equipment. I'm not sure I'll fit. Maybe over here in this wall. But let me just remind everybody that the next board meeting, you're more than welcome to chime in. Just email Jim, and he'll get you a link. Will be April 17th, and of course, the next club meeting is May the 3rd. Don't forget that in May, PAARA is going to be sponsoring the next electronic flea market, and that's actually going to be the 19th, I understand, because the 14th is Mother's Day, so they're bumping it up, and we're going to need volunteers for that. If you're interested, Jim would love you to email him. All kinds of tasks we need you guys to do, whether it's early in the morning or in the afternoon when we take down. So, any other business? All right, thanks again, everybody, for the late start, but we got everybody in, and that's the goal. And anybody on Zoom, thank you for being there. We'll be back next time. Yo.
Didn't hear what you said, Doug. You're on mute.
Seven three, everybody, from N6 VF8.
7-3 to you too, Chuck.
A73 K7ILA.
Yeah, good to have you with us again tonight, Pink. Take care.
Thank you. You too.
73, everybody.
Have a good evening, Joe.
I really enjoyed it. It was really good. And my favorite amateur radio video is got uploaded to YouTube. The chick in the sports car, the blonde, that made me get my license in the 60s when I was a kid.
Very good. All right, good night, all.
A lot of heat, kid. I see a lot of green paint. Good night, everybody. Yeah, now that I'm 150 miles away, you guys found a place to have pizza.
Is everybody here? Oh, there's Joe. All in here? Thank you.
Thanks, man.
Yeah, I'm surprised nobody mentioned that there's about 100 watts of RFI next to that loop antenna.
All right, now we have great stuff. Say this, so we can perfect your face, Tom. Did you name it or name it? No, Andy. You don't want it. You give me some anything. Oh, let's do it here. Definitely.
Hey, Doug.
A lot of new faces I didn't recognize tonight.
Doug.
Okay, things are winding down here, so I'm gonna pull the plug on Zoom. Hi, everybody.
Okay.
Hi, Doug, 7-3, N6 VFA.